Dear children, welcome to our class. In this module, we are going to learn about the prime numbers. Already you know about odd numbers, even numbers. In this module, we are going to learn about the prime numbers. What is meant by prime numbers? Let us see with some examples. Already we know that this is the multiplication fact. Here each numbers are called as factors and this is called as product or multiples. We know that the division is used to distribute it equally. We want to share our things equally without the reminders. So that is the use of division. So multiplication table is very important to do the division. So both are related to each other in the equal distribution. Let us see some example. Here I have 4 candies. 4 candies. I want to share it equally. How can we share? In how many methods I can share? Let us see. I can share these 4 candies to one child. So one child can get 4 candies. So the factor, how can we write the factor? 4 multiplied by 1 is equal to 4. Or we can write one kid get 4 candies. So that is 4. Here there are 2 children. We want to share the same 4 candies to the 2 children. How can we share it? So we can give 2 candies equally. So that candies, we don't have any left out candies. Here we shared the 2 candies to 2 children. So in mathematical way, we can write 2 multiply 2. 2 candies divided to 2 children. So totally we have 4. We distributed the 4 candies. 2 into 2. So this is the multiplication fact related to this picture. By 2 methods we shared. In first example we have 1 child. In the second situation we have 2 children to share. Now there are 4 children and 4 candies. So how many candies each one will get? They will get 1. So 1 can give to one person, another one can be given to another one can be given to another one. So totally 4 groups. We can separate it as a 4 groups. So that can be written as 4 multiply 1 is equal to 4. So we can write like this. So with the above situations, we have 2 multiplication facts. 2 multiplication facts. 1 multiplied by 4 is equal to 4. 2 multiplied by 2 is equal to 4. So we have 2 situations. And how many facts are there? So the numbers which we used in the multiplication, these are all called as facts. So we can say I have 1, 2 and 4. Here we have 2 2's. No need to write 2 times 2's. You can write 1 time, enough. So here the factors of 4 are 1, 2, 4. So the 4 candies can be given to one child, or it can be divided to 2 children, or it can be divided to 4 children. So that is the factors. Without the remainder we are distributing. So that is called as factors. So without remaining, if we can distribute, that is called as factors. Understand children? Now let us see another one example. Like the same situation, here we have 6 candies. 1, 2, 3, 4, 5, 6. 6 candies are there. we have only one child, so we can group it one and we can give all the candies to one child. So 1 multiplied by 6 is equal to 6. Here you must know that 1 6 are 6, 6 ones are 6. So if you change these two terms, if you are using the interchanging the factors also, we will get the same thing. So both are equal. Okay. Next we have same 6 candies, and now we have 2 children. If we can share it one child. In the same way, if we have 2 children, you can group it into 2. We can group it 2. So each one will get 3 candies. 1, 2, 3. 3 candies can be given to one child. The remaining 3 can be given to another child. So here also we don't have any remainder. So we don't have any left out. Remaining will not be there. So this candies can be distributed equally. Again, if we have 3 children, that also can be grouped into 3. So 3 2s are 6. Actually, I told that the two things are same only. So we have 3 multiplication facts. We can get 3 multiplication facts. Actually, we can get 2 multiplication facts. 1 into 6, 2 into 3. So like that we can get it. So this is the repetition of this one. Again, we can write another one multiplication fact. 1 6 are 6. So this is a repetition of this one. So both are equal. These two are equal. Now let us write the factors of 6. The factors of 6 are 1, 2, 3. So this number has 3 factors. 1, 2, 3. See, so these 3 are the factors of 6. With the same example, we can clarify some more thing. Now I have 7 candies. 1, 2, 3, 4, 5, 6, 7. 7 candies are there. Now I want to share with some children. If I have one child, I can share it with one children. Everyone I can give to the same child. So that one child will get all the 7 candies. So 7 into 1. 7 ones are 7. Okay. Now, can you give to 2 children? Just you can imagine that if you are giving to 2 children, how many we can give? You can group 2. 3 we can give. The another one is remaining. So definitely this cannot be divided by 2. We can't share the 7 candies to 2 children. It is not possible. And also we cannot share the same thing to the 3 children also. If you share to 3 children, again you will get one as a remaining. So that is not shared equally. Finally, we can share the 7 candies to 7 children. Each one will get 1. So the factors of 7 candies, the factors of 7 is 7 into 1 is equal to 7. 1 into 7 is equal to 7. Only 2 multiplication facts we got it. Actually, this is 1 multiplication only. We have 7 and 1. Let us write the factors of these. The factors of 7 is 1 and 7 only. We don't have any other factors. Let us see another one example. I have 5 candies. So this 5 candies also shared equally by 5 children or 1 children. Okay. All the 5 candies can be given to 1 child, or we can give to one child. That's all. 5 children are there. So we can give 1 candies to 5 children. This cannot be separated by 2 children. We can't share to 3 children. We can't share to 4 children also. It can be shared only by 1 child or the same number of candies. So 5 children. Okay. So the factors of 5 is 1 and 5 alone. So the factors of 5 is 1 and the same number 5 alone. Such numbers are called as prime numbers. Such numbers are called as prime numbers. Let us go to the another one example. Here I have 31 candies. So if I want to group it equally, means I can group only one group. I can make it as one group. I can give these all the 31 candies to one child, or we can give to 31 children equally. We can't separate it, we can't group it two groups, or we can't make three groups, or we can't make four groups, or any number of groups. We can't make it equally. Without remaining, we want to make it. That is important. So here we can make it only two groups. It may be one group, or that number 31 groups we can make it. So such numbers are called as prime numbers. Such numbers are called as prime numbers. Literally, we can say that each number only have two factors, no other factors except for one and themselves. Such numbers are called as prime numbers. We can say that a prime number is a number which can be divided exactly by two different numbers, one and itself. Such numbers are called as prime numbers. In our example, 31 is a prime number because we can give 31 chocolates to one child, or we can give 31 chocolates to 31 children. That's all. So it has only two factors. This is called as prime number. Here I have given numbers from 1 to 10. I have written numbers from 1 to 100 and I shaded with yellow color. That shaded numbers are the prime numbers. 2 is the prime number, 3 is the prime number, 5, 7, 11, 13. If you think about the 13, you can take any one of the shaded number. You can take 13 or 43. If you are taking the 43 candies can be given to one child, it can be given to one child or 43 children. That's all. We can't group it any number of groups. We can't group it to, we can't make 3 groups with the 43 candies. We can't make 4 groups with the 43 candies. You can think over all the numbers, whatever it may be. We can't separate it without the remainder. So this 2 alone is a possibility. So such numbers are called as prime numbers. So here we have given some prime numbers from 1 to 100. From 1 to 100. Most probably all the numbers, all the prime numbers will be the odd numbers except 2. Except 2, all the other numbers are the odd numbers. If it is even number, definitely it can be divided by 2. So here you can check all the other numbers. The numbers are only the odd numbers. We can't say all the odd numbers are prime number because 15 is the odd number, but it can be divided by 3 groups, 5 groups. So it's not applicable. But some odd numbers will be the prime numbers. So except 2. So here I can say the shaded numbers are prime numbers. Then what about the unshaded numbers? What about these? So these numbers are called as composite numbers. These numbers are called as composite numbers. When you are learning about the prime and composite numbers, let us see some interesting fun facts are there. See, 2 is the smallest prime number. 2 is the smallest prime number. It also the only even prime number. All other even numbers can be divided by themselves. 1 and 2 at least, meaning they will have at least 3 factors. At least 3 factors. So only the 2 is the even prime number. And you may have a doubt whether 1 is a prime number or not. Is 1 a prime number or not? 1 is not a prime number because it has only one factor. we can write 1 multiply 1 is equal to 1. Other than that, we don't have any other numbers. So we have a factor, 1 is a factor of 1. So this is not a prime number. Prime numbers need to have exactly 2 factors. If a number has 2 factors, we can say that is a prime number. It has only 1 factor. So the 1 is not a prime number. So let us remind that 1 is neither a prime number nor a composite number. It is not a prime number or it is not a composite number. The only even prime number is 2. No prime number greater than 5 ends in the number 5. Only the 5 is a prime number. Other than that, the numbers which ends with 5 is not a prime number except the 5. Let us recall you again. If a number has only 2 factors, that number is called as prime number. For example, 13 has only 2 factors, itself and 1. So it is a prime number. Yes, children, I hope that you are clear about the prime numbers and composite numbers.